Hey guys, what's up? This is Paul 80 from Cyber 80 Forensics. And today I wanted to talk about another obscure but equally important Velociraptor function, and that is the dead disk forensics. Now, if you're saying, Paul, what the heck is the dead disk forensics? That is where your boss or somebody drops a hard drive on your desk and says, go ahead and analyze this image here for forensic artifacts, signs of intrusion. So what you may be doing already is using some type of premium software like Encase or Axiom, plugging in this image, whether it's an EO1 or RAW, and then grabbing a Snickers bar and waiting like 24 hours or so to go ahead and process the image. Or you might be using tools like the Eric Zimmerman tools from GitHub to rip the image manually, which I do frequently. But now here's another option, and that is to analyze your disk image with Velociraptor using the dead disk analysis. And within minutes, you're going to have a lot of interesting forensic artifacts that you can now look at. So the dead disk analysis with Velociraptor has probably been around for a while. I'm not sure how long, but by looking at the documentation, which is quite extensive, the documentation appears to be kind of old and outdated. I mean, there's a full page here. We even got another page on just the dead disk forensics right here. But there are some things that are lacking in the documentation, and that is there's not a real clear description on how to collect this evidence. And there's also not a description on what works and what doesn't work with this process. I've taken a look on YouTube and I did not see any videos out there on how to do dead disk forensics with Velociraptor. So I was kind of excited. I said, let's go ahead and make a video because this can be pretty important to everybody and quite helpful. So let's sit back, relax, and jump in knee deep and take a look at the Velociraptor dead disk forensics. Okay, so if you guys saw my other video on the Velociraptor offline collector, you probably saw that I was using a Windows operating system and I was using the Windows executable to set up the server. Well, that's not going to work in this case with the Dead Disk Client. I spent a considerable amount of time trying to get the Windows server to work, and I just kept getting so many errors, it was getting ridiculous. So I started using the Linux executable to create the server, and that worked like a champ. As you can see, I'm using a Linux Ubuntu operating system, and this is Ubuntu 24.04. So let's go ahead and get the Linux executable, and we'll start here. I'm just going to do a search for GitHub, Velociraptor, and here's our page on GitHub, Velocidex, Velociraptor. Let's go to the right side. We'll go to the releases. We're at 75 release. I filmed this in February of 2026. So we're at version 75.6 is our latest version. So we'll scroll down towards the bottom here. We're going to find version 75.6 Linux AMD. Or this one right here. Okay, so 75.6 Linux AMD 64. That's the one. I've got an AMD processor. Probably most of you do as well. Let's click on that one. All right, that's going to go into our downloads. Let's switch over to our terminal at this point right here. Let's give us super user privileges just to make it easier. So we'll do sudo su. Type in your password. And then after you got your password in, let's navigate to our downloads folder. Let's do an ls-tac-lh. And as you can see, as expected, we just have read-write permissions on this. Let's make it executable. Let's go chmod plus X. And then our Velociraptor Linux executable. Hit enter. And if we do ls-tac-lh, we'll see we now have read-write execute permissions across the board, which we're going to need to set up our server here. From this point, we're just going to go /Velociraptor, and we're going to say GUI. No need to set up another data store. We can just leave it as is. This will go into the temp directory in Linux, and it's a lot more persistent than the Windows version. We hit enter, and the server starts kicking off right there. Now, the Linux version is not going to launch the web page automatically. We kind of have to do it ourselves. So let's just get a web page. We're going to type in https://127.0.0.1 : and our port is 8889. That's our GUI port right there. Hit enter. We get this potential warning here. We click on advanced on the right side, scroll down, and accept the risk and continue. The default username set by Velociraptor is admin, and the password is password. Like I say, these were set up by default for the Velociraptor instant servers. So username admin, password, password. Hit sign in. Okay. Since we're at this page right here, I'm going to do something similar to what I did in the offline collector. And I'm just going to go to this step right here, the import extra artifacts, because we're going to use this in a bit. So the import artifacts is going to potentially get all 6 of these right here. We go to configure parameters on the bottom. Let's expand this right here. The only one I want to use for now is this top one right here, which is the Velociraptor Sigma project. So I'm just going to trash can everything else and hit launch. Within a couple seconds, this should go to a check mark, which means that it'll be completed. And there we go. So it's been downloaded. At this point, I'm going to click on the hamburger on the left right here, and we're going to go to, well, we're already in server artifacts, but if you get lost, just go back to server artifacts right here. We're going to click on new collection, and what we're looking for is the Dead Disk Client, Server Utils Dead Disk Client, this one in the middle right here. Click on that. And we go to configure parameters. Let's expand this a bit here. Now let's talk about this for a moment. We've got 3 things that we can potentially do. Image path, host name, write back file. So the image path, if you look at the documentation, they say that it works on EO1 files, raw, VMDK files, and then also the Windows Hyper-V, VHDX files. So I've tested all these extensively. The ones that work are the EO1 images that are a physical disk image, i.e. it's a disk image of the entire disk, as opposed to a logical image, which is just like the C drive only. So EO1 files, physical disk image, those work. A raw image, a raw physical image, that works. The VMDK, which is which is the VMware virtual machine hard disk, VMDKs, those work great as well. What does not work also is, from my testing, is the Windows Hyper-V VHDX. Those hard drives, those virtual hard drive files, I could not get them to work. So what I'm going to do, everyone's probably using an EL1 image anyways, so I'm just going to go ahead and put in an EL1 image. I'm going to drop in my path right here. I've got a disk image of a computer called PC03, and this is a physical disk image, the entire disk image for PC03. Like I said, keep in mind, EL1 files, if it's a physical disk image, good. Logical image, bad. And also the VHDX, the Windows Hyper-V, just does not work as well too. So I can throw in a raw file here, an EL1 file, a VMware VMDX, that could go in here as well too. Now the host name, this will not automatically pick up the host, kind of like the offline collector did. So I'm just going to say PC03 and put a little tack in the middle right there. The write back file, we can leave that default. This goes to the temp directory of Linux and it drops it in there. And the temp directory, like I said earlier, is not volatile like in Windows, where stuff just gets deleted out at random. And that's it right there. Okay, one more thing we got to tweak. We go specify resources. By default, the dead disk will run for 3,600 seconds, which is 1 hour. If you need more time, like for example, I'm going to make this 7,200 seconds, so I've got at least 2 hours to look at this image. If you time out, it's not a big deal. You'll just find that your hunts are kind of, they're not completing, and they never will complete, so you can kind of go back and you can run this entire process over and you'll pick up right where you left off. But to give you more time, just throw in a larger amount of time here. We go to launch, and you'll see that it's scheduled right here. This may stay scheduled for a while. If you want to take a quick peek, make sure that things are going okay, go to your log right here and make sure that there's no errors. Any kind of error would show up in red. And there'd be some type of mounting issue or disassembly of the Windows operating system to put it in, and I don't see any problems like that, so we're good to go. Like I said, this will stay scheduled. I'm not sure that, I think it eventually gets to a check mark, but that might take a while, so it's not a problem. We can continue on. We go to the little caret at the top and we go show all. Here is our PC03, or dead disk. This is my client right here that's running in the Linux operating system. So we don't want to look at that, but we want to look at is this PC03. So we click on the client ID, and we go to collected up top here. From here, if we go to our notebook, we can see that there's already some information that's been collected by default. You've got this generic client information right here. This shows the type of Velociraptor. We got 75.6 that we're running. Our host is PC03. And you've got some other information. It's a Windows operating system, no big surprise. And then this is kind of cool right here. They show your users. It looks like this is taken out of the software registry hive. But it'll show all the users, and then it'll show the last login times for these users. So that's kind of fun to have right there. Let's go back up to the top right here. If you're going to run just one hunt and that's it, this is what I would recommend that you do. So we go to new collection up here and type in Hayabusa. So this was the extra artifacts that we downloaded in the very beginning. So you've got Windows Hayabusa rules. Like I say, if you're going to run just one thing on the hard drive, do this one because it will help you out a lot right here. There is about 4,000 plus Sigma rules that are used and are kind of thrown at the hard drive image to find all sorts of bad things, anywhere from Windows Defender was turned off to stuff like Mimikatz was downloaded and executed to DLLs are in the wrong directory, executables that are running out of System 32, all sorts of things that look wrong. You don't even have to touch the configure parameters. There's a bunch of stuff that could be configured. I just leave it default. And we go to launch right here. Now, unlike the instant Velociraptor, this thing will kick off automatically right here. So it goes waiting to run. It's actually running right now. And so if we click on it here, give it just a moment, here it is. It's going to take a while to run, but we can still look at what it's processing right now. If I go to Notebook, kind of click on the white space here, go recalculate, give it just a moment. It needs to, I'm going to refresh it again. Let's take a look at our log, see what's going on. Okay, so it has 4,700 Sigma rules overloaded. That's good. It keeps getting more and more rules all the time, which is a really good thing. Here we go. Finally loaded. I'm just going to edit the cell real quick, and I'm just going to take out this limit 50 so we get all of our rules. Hit save and run. So keep in mind this rule is still running. It hasn't finished. It'll find more, but right now we have 949 hits. And what Velociraptor, the Hayabusa does is it puts it in levels anywhere from informational to low to medium to high and critical. I typically look at the highs and criticals, and sometimes we'll dabble in the mediums. And you'll find some good stuff right there. So if we wanted to, we could go ahead and we're going to do what's called stacking. So we go to where it says sort. I'm going to single click on that. Give it a moment, depending on how much data is in there. This happened pretty quick, and we go stack. And this will show us we have criticals. We have 6 critical hits. We have 11 high hits. And like I said, I tend to not look at the informational lows. I may look at the mediums, but I'm definitely going to look at these first. So like, for example, criticals, I'm going to click on that on the link. And you can see right here, we got a Defender alert, Trojan, looks like in the user Mary Jane Mimikatz. We've got, it looks like a zip was put into the downloads folder. So you can look through this, and we could do the same thing if we wanted to with the high alerts as well too. So this will find some really good stuff. This is a good way for you to kind of start your investigation right here. Hayabusa also has a executable that you can download from GitHub, so you could do this, manually if you wanted to. It looks at all of the, or most of the important, the Windows event logs, and so it looks for any type of malicious activity in the Windows event logs. Now, some of the other stuff that we can run here. Now, keep in mind, this is a disk image. This is not going to have any type of live information. So stuff like PS list, PS tree, netstat, DLL, those are not going to work because that information is taken from the memory or while a computer will be running live. So you're not going to get any of that type of information. But you can still get stuff like, let's take a look at prefetch here. I'm just going to run this default, and this should load pretty quick. Let's recalculate. It's still running. You can see our Hayabusa is still running right here. It's finding more and more rules. So check back with that later. You might even find some. Oh, it's done. Okay, Hayabusa's done, and their prefetch. So here's our prefetch right here. So if you want to look for evidence of execution, prefetch is good. I'll put a list of all the hunts that I like to do that I found that actually work, and some of the hunts that don't work. I mean, we could take a look at Amcache if we wanted to. Now that we're talking about evidence of execution, let's launch that. That one went pretty quickly right there. Here's our Amcache, showing another look at the evidence of execution. One hunt I found, I've done this a bunch of times, and one hunt that just does not work. I cannot get it to work at all, period, on the dead disk forensics. This works great on the offline collector, works great on the live collector, but services, it just does not work. I'm not even sure I've ever gotten it to work on the dead disk client right here. Let's try it, and it loads really quick, and then you'll get no data. So services, for some reason, and you can see right here, it looks like call to plug in WMI disabled. So we got some trouble here. I guess it's using WMI to find these services, and perhaps because this is just a disk image, it's unable to do that. So the artifacts that do not work are, like I mentioned earlier, PS list, PS tree, netstat, DLLs, and throw services into the mix as well too. But other stuff like scheduled tasks, these work great. Remote desktop connections, Windows Remote Desktop Protocol. This is one that I love right here. This one works really good as well. That's going to show any type of RDP activity, which attackers like to use a lot to move laterally throughout the network. So you're going to get that. Your master file table, this thing works fine right here. It might take a bit because it's going to be quite large, but master file table works. USN journal, those work as well too. And a whole bunch of the hunts work pretty well. So, but just keep in mind, you're going to be limited a bit on some hunts that will not work, like the ones I mentioned earlier, right there. One more thing to mention, you cannot do multiple hosts at one time, like you can with the Velociraptor Live, where you could get, hundreds or thousands of hosts. You got to do one at a time. If you wanted to add another client in here, let's say like PC04, you would have to go ahead and restart the process and then put the image path to PC04. That's going to kick out PC03, or it's going to make this unusable right here. So that is the dead disk forensics with Velociraptor. Just a couple things to keep in mind. Once again, you got to use a Linux executable. So set up a Linux server, and you got to be kind of particular about the images that you use. Physical images work, whether it's EO1 or RAW. Logical images do not work. Your VMware VMDK files, those will work, and the Windows Hyper-V VHDX files, those do not work, or at least I cannot get them to work. Keep that in mind. And also keep in mind that the dead disk forensics, although it's really great, there are some better options. Your first choice would be to do the Velociraptor Live. You're going to get a lot more data. So if there's an internet connection, and you can go ahead and set up a server in the cloud, Velociraptor Live is the way to go. If you can't do that, then probably your second best option would be to do a Velociraptor offline collector. I'll put a link in the description for the video I did on that earlier. So offline collector is going to be better because then you can leverage stuff like, the PS list, DLLs, etc. services, because you can collect those pretty easily with the offline collector. But if none of those options are available and someone just hands you a disk image, you still can do stuff. You still can do a fair amount of forensics with it using the processes that we just described here with the dead disk forensics. So that's kind of your third option right there. But sometimes you don't have any other options to use. So that's going to be it. Once again, Paul80 from cyber80.com. Hit me up in the comments if you have any questions or you want to see any other stuff about Velociraptor. Thanks, guys.